Hello everyone, in this video we will discuss about types of error measures. Numerical methods, whenever we approximate a value, an important question comes, how accurate is our approximation and how we measure the accuracy of that approximation. So in this lecture we will focus on some error measures to get an idea of accuracy. So let us understand the types of error measures used in numerical methods. We define two values, true or exact value that is denoted by capital T and approximate value is denoted by capital A. First is true error. True error is denoted by ET and it is defined as true value minus approximate value. True error shows actual deviation from the true value. If true error is positive, it means our approximation is underestimate. If error is negative, it means our approximation is an overestimate. Underestimate means approximate value is less than true value. Overestimate means approximate value is greater than the true value. Next is absolute true error. It is the absolute value of true error. Okay, so absolute value of true error is called absolute true error. Absolute true error tells how far the approximate value is from true value. It gives only the magnitude of the error. It ignores the sign. Next is the most important one, that is relative error. It is defined as uh, absolute true error divided by absolute true value. Relative error tells us how large the error is compared to the true value. So relative error becomes important when true value is very large or very small. Finally, we have a percentage error that we denote by EP, and it is defined as ER multiplied with 100. Means percentage error defines the relative error in percentage form. That is very easy to understand and comparison purpose. Now let us discuss two examples. In first example, true value is 10.5 and approximate value is 10.4. In second example, true value is 0.5 and approximate value is 0.4. So absolute true error, for example 1, it will be true value minus approximate value, so it is 0.1. And relative error will be absolute true error divided by absolute true value, which is approximately 0.0095238. Now percentage error will be 0.95%. It is obtained by multiplying ER with 100. So in example 2, you can see again absolute error we are getting 0.1 as a true value minus approximate value. Relative error, absolute true error, which is 0.1 divided by absolute true value. So we are getting 0.2. Percentage error, we multiply ER 0.2 by 100. So we are getting 20%, which is percentage error. So here both examples have the same absolute true error, but percentage error is different. You can see from here. In example 1, percentage relative error is less than 1%, which is very small. So we say that approximation is good or approximation has good accuracy. In example 2, percentage relative error is 20%, which is quite large. So we say that approximation is poor, or approximation has poor accuracy. So now we can clearly see in both examples, absolute true error is same, but still accuracy is different. In example 1, approximation is more accurate than the approximation is example 2. Therefore, we conclude relative error gives a better idea of accuracy. So friends, if you found this lecture helpful, please like the video, subscribe to the channel, share with your friends, and if you have any doubt or question, you can write them in the comment section. Thank you very much.